Today in electromagnetism, we will start with basic idea of electromagnetism, right? In basic idea of electromagnetism, you already know that we discussed about, let me show you notes. Okay, this is the very first topic related to electromagnetism in which we discussed that when current passes through the conductor, so magnetic field creates around it. Okay, so in electromagnetism, we discuss about this right hand grip rule. So this is the very first idea when electric current passes through the conductor. So it will generate magnetic field around it. So this is a general concept, first concept related to electromagnetism. After this, we discuss the concept of into the paper, out of the paper. And in that, we also practiced that how to draw the magnetic field around the conductor, concentric circle, increasing gap, right direction. So this is all the concept that we have to discuss. We will start past paper question. This is like a short revision of the topic. And then we also discussed that if coil is circular or a solenoid, so definitely current moves in a circular form. Magnetic field will not be in a circular form. So we just switch the positions of the thumb and the curl of the finger. So the thumb represents the north pole, curl of the finger represents the direction of electric current. And one more idea that we discussed when we have two conductors placed close to each other and the direction of electric current are same for both. So they generates magnetic field that attracts towards each other. So that will form force of attraction. And in the opposite side, if we compare the opposite direction of electric current, like electric current is moving in opposite direction in the conductor, so that will create force of repulsion. So we also know that how is the pattern of the electric field lines when there is force of attraction and when there is force of repulsion. So this is the first idea of electromagnetism. And after this, we discuss about Fleming's left hand rule. In Fleming's left hand rule, we know that the magnetic field and electric current is given. Force is unknown in the Fleming's left hand rule. So this is the important thing we have to keep in our mind. And DC motor is the application of Fleming's left-hand rule. So today we will practice questions related to Fleming's left-hand rule and electromagnetism only. So it will also helps to like compare the questions or to differentiate between the questions related to left-hand rule and right-hand rule, right? And in this, we know that if current is already given in the question, magnetic field is already given. So definitely we have to apply Fleming's left-hand rule. And let's suppose if the value of electric current is not given and they are asking about to find out the direction of induced current or to find out the value or the direction of induced EMF. So that is related to the right-hand rule. Okay. So today we are not going to discuss about this right-hand rule. We will practice the questions of right hand rule after completing the questions from left hand rule and electromagnetism. And we know all three quantities, force, magnetic field, electric current, three of them are perpendicular to each other. And there are some factors also, like if we use a stronger magnet, so that a stronger magnet will automatically increases the value of force. If we are using a high value of electric current, so that will also increase the value of force. And if we are using um greater number of turns in wire or a long conductor, so that will also creates a greater force on the conductor, right? And then we have a concept of DC motor, and we know that how DC motor works. Same, we have like split rings, and in split ring, what we have there is like a split between the ring. And why there is a split? Because in horizontal position, coil rotates with maximum force, but in perpendicular position, there will be a like minimum turning effect or minimum torque in the coil. So to continue the rotation, we keep the gap in between the coil. So due to inertia, there is no current flow from this gap part of the coil. So coil continues rotation in the form of inertia, and one side moves in upward direction, second side moves in downward direction, just like the steering wheel of the car. So basically, it will supports the rotation of the wheel, and that will give you a complete rotation in one direction.
Sorry, what is inertia again? I've forgotten.
Inertia means if body is in motion, so it will continue its motion until it is acted upon by any resultant or external force. So half of the rotation already
Oh,
completed with the help of electric current, so half of the rotation automatically completes with the help of inertia. So let's see how the questions are related with the Fleming's left-hand rule and electromagnetism. So we have to find only the questions related to the DC and electromagnetism. So in October, November 23, we know there is a question related to AC. This is related to AC, so we skip this part. Electricity, we already done. Electricity, electrostatics, transformer, AC, homework question, electrostatics. Hmm. So question number 11, because, okay, in this question, you can see battery is already given, right? So battery given, it means electric current is uh, moving through the solenoid. So that's how we identify that this question is from like concept of DC. It is not related to AC. So in this way, you can identify the questions. You can also differentiate questions by yourself. So it will be easy for you to apply the concept. If you are confused in AC and DC, that which concept is applicable on this one. So it will be difficult for you to solve the questions because you are already confused in AC and DC. So it is very important to know the concept, that which concept you have to apply on the question. So in this question, there
sorry,
is a
what paper is
solenoid.
this?
Hmm?
Which paper is this? And like, what's the code? Is it year 2023?
This is from 22, October, November 20.
Okay, it's maybe I have it.
Yes. Because
Okay, I'll
in
check.
23,
Is it paper four?
paper 4, variant 3, yes. So in this question, current is already given. And on figure 11.1, draw the pattern of the magnetic field inside and around the coil solenoid. Indicate the direction of the magnetic field with an arrow. So basically, we know that electric current is moving through the solenoid. So again, this is the idea from electromagnetism. When current passes through the conductor or through the coil, magnetic field generates around it. So we have to draw the pattern of magnetic field. Okay. So first of all, you have to draw this diagram. So current is moving in this direction, and it will move in this direction from the front of the coil. So basically, if we zoom in into the diagram, so you can see when current passes through the coil, so you can see current moves from the front of the coil towards left, and it will move towards right from the back side of the coil, right? So what will be the direction of north pole? Or how to identify the direction of the magnetic field from this diagram. North will be like upward or downward. So when you curl your fingers, so your finger will get curved like this, right? So this is the direction of the curl of your finger. So it means your thumb will be directing in downward direction. So it means that magnetic field line is moving from upward to downward direction like this. So this is the direction of the magnetic field from the center. And from right hand side, from left hand side, we know that there is like a curve shape. Same on the other side. So this will represents you the direction of the magnetic field lines according to the direction of electric current. So it is like the same idea we discussed over here, right? So when current is passing, so from this diagram, you can get the reference that how the direction of the magnetic field is moving. So from north, like we draw from the center, and you can also mark these two lines which are slightly curved, not completely straight. So we will also make like this. Right? So this is the same diagram. If you flip this diagram, so you will get the same idea, just like the question in this way. You can see current is moving like this. So you are getting same diagram in this question, right? Because you are getting 3 marks. So for 3 marks, definitely you have to draw the center lines to show the pattern and one right hand side, one left hand side curve pattern to complete your diagram. So that's how you are getting 3 marks over here. Okay, next part is related to transformer. So just hold that part for AC generator and transformer topic. It is also related to AC supply. This part is related to magnetism. Like this question is about the magnetic fields around the bar magnet. It shows two positions used by a student doing an experiment, position 1, position 2. Figure 7.2 shows a magnet labeled magnet 1 placed on position 1. So magnet 1 is placed on position 1. Okay, we have south on left, north on right. Then we have position 2. On figure 7.2, draw lines to show the pattern of the magnetic field produced by the magnet 1. Place arrows on the lines to show the direction of the field. So we also need to place arrows to show the direction of the field. So again, we know that from north to south, field will move out from the north inwards to the south. And again, if you remember, to increase the distance, so that increase in distance shows you the weak magnetic field away from the magnet. So you have to increase the gap between the field lines to show the idea of the weak magnetic field, because that will also give you mark for the representation. And we also draw the arrows, because they ask to draw the arrow to show the exact direction. Now let's see in the next part. Magnet 1 is removed from position 1, and figure 7.3 shows another magnet. Draw label magnet 2 placed on position 2. Okay. So now we have magnet 2 placed on position 2. On figure 7.3, again draw at right hand end of position 1 a line with an arrow to show the direction of the magnetic field produced by magnet 2. Again, you have to show the arrow to represent the direction. So basically, now you have to draw at right hand end of position 1. So basically, they are talking about this right hand side of position 1, and a line with an arrow to show the direction of magnetic field produced by magnet 2. So basically, this is only for 1 mark. So you don't need to represent whole diagram, just like we represents in the first part. So from North Pole, it will be like moving from north to south. So definitely from north to the position 1, there is a straight line and it is pointing towards the left. Because in both statements, you can see, if you compare this statement, it asks you to draw lines to show the pattern of the magnetic field. So this is completely different. And in this statement, you can see the right hand of position 1. So in both questions, these are not same. They are asking different things in both questions. And they only ask to draw a line with an arrow. You can see line with an arrow. So that's why we only draw one line on the right hand side of position 1 produced by magnet 2. Because at position 1 we have nothing. There is no magnet in position 1 right now. It was there in diagram 7.2. Okay, now in part C we have two magnets in two positions. Same magnets on their same position, just like in previous two diagrams. So state the direction of the force. North pole of magnet 2 exerts on the north pole of magnet 1. So basically we know it will be like this. We know north and north will repel each other. Now we have to state the direction of force that the north pole of magnet 2 exerts on north pole of magnet 1. So it means the north pole of magnet 2 exerts force on magnet one, that will be repulsive. So from north pole, definitely it will be forced towards left hand side. Force away from magnet two, or you can write towards left hand side, because the repulsive force exerted by north pole of magnet 2 will be towards left hand side, and from magnet 1 it will be towards right hand side, like this. So they are asking about this position. And now you have to justify your answer to part C1. So it will be because of magnetic field lines. So if we just make magnetic field lines of the North Pole, so that will show you the answer. Okay, before starting new question, there is one more question. Like in many different forms of the questions we got, like sometimes they ask state and explain, or sometimes they only mention describe, and sometimes you got explain, and also sometimes they ask like state and describe. So uh, how to differentiate, or like what answer we have to write when questions ask you about explain and when they ask about describe? So how we differentiate and what answer we have to write between these two statements? Because in science exam papers, you know that you will get these terms commonly. Sometimes we got state and explain, sometimes we only got state or and describe, or sometimes we got only describe or only explain. So basically, always remember when they ask about explain word, right? So explain word means you have to apply any scientific formula, any scientific knowledge, any scientific relation, or any link, whatever the question is, right? Like in terminal velocity, or we are doing electricity. So let's suppose we have a concept of left hand rule. So this is like physics, proper Fleming's left hand rule. So we have to write the answer or write the keywords. So in marking scheme also, you will find in the questions, in some questions you will get many key terms like Fleming's left hand rule, by using left hand rule, show direction of force. So they use slash, 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 many options, right? So if you notice, you will find that answer mostly in the questions when they ask the word explain. So whenever they ask the questions related to the explain, so try to write or try to relate all the scientific knowledge you have about that question. And if there is any formula, because in physics normally we have formula, So try to relate that formula, or if you have any direct or indirect relation, so show that relation also. And when they ask about describe, right? So in describe, it is not compulsory to show all the scientific reasons, right? You don't need to mention all the scientific reasons. Describe is like in simple words. Let's suppose if someone asks you about the working of anything, so that means describe. So in describe type of question, you don't require so many scientific knowledge and scientific reasons to write in your answers, right? If you are writing, so that's good, but it is not required. But it is very important to write in explain questions, right? So whenever you got the term explain, so state means just one word, one line answer, simple. But when you got the part explanation, because in some questions you find that they also ask by themselves in terms of particles explain. So they already give you a reference that use this reference to explain this idea. Like in thermal, we got similar questions, most frequently collision, force increase, momentum increase, like this. Okay, electromagnetism AC, homework question. Okay, let's try this one. This is like a mixed electricity and magnetism question. It shows two vertical cylindrical tubes and a cylindrical magnet, all held in a vacuum. So we have a plastic tube and a copper tube. Okay. And there is a cylindrical magnet, very short as compared to the size of the tubes. So one tube is made up of plastic, other is made up of copper. They have identical dimension. It means length, width, height, all things are same, completely ditto copy. And the magnetic field of, okay, magnetic field of a small cylindrical magnet is extremely strong. Okay. So magnetic field is extremely strong. Initially, the magnet is at rest at the top of the plastic tube. Okay. Magnet is at rest, top of plastic tube. Then magnet is released and it falls through the plastic tube without experiencing a resistive force. Because we know it is plastic, so definitely there will be no resistive force on it. And the next part of the question is, the magnet takes 0.67 seconds to fall to the lower end of the plastic tube. Okay. The mass of the magnet is 0.012 kg. Mass is given, time is given. Calculate the kinetic energy of the magnet when it reaches the lower end of the plastic tube. Okay, so we have to find out the kinetic energy first. Okay, we know that the formula of kinetic energy is equals to half mv square. So we have mass, we have time, and yes, we have only these two values given in the question, mass, time. Distance is not given. Plus, the magnet is released and it falls through the plastic tube without experiencing a resistive force. So there is zero resistive force, right? So resistive force is zero. It means body moves in downward direction with acceleration due to gravity. Because when there is no resistive force, no resistive force means if you consider free fall motion. So in free fall motion, there is air resistance. But if there is no air resistance, so all bodies fall with acceleration due to gravity. That is equals to 9.81 in new paper pattern. So according to that, if we use the formula of acceleration or velocity, like acceleration is equals to Rate of change of velocity. Velocity is equals to acceleration into time. So acceleration, we will use acceleration due to gravity, like in free fall motion, because there is no resistive force. So there is only one force that is moving in downward direction, which is equals to the weight of the body or the downward force. So that is equals to 9.81 free fall. Time is 0.67 seconds. So this will be equals to the velocity. So velocity is equals to 0.67 multiply 9.81, 6.5 meter per second. Secondly, now we can find out kinetic energy. Half mv square 1 over 2 mass is equals to 0.012 multiply by 6.5 square. So it means multiply by 0.012 multiply by zero point 0.5. So it will be equals to 0.259. Or in two significant figures, we can write 0.26 joules. Right? So this is the value of kinetic energy for this question. Okay. Now the magnet is then held at the top of the copper tube and released. As it falls through the copper tube and electric current is generated, right, in the copper. So explain why there is a current in the copper. So basically this is the idea linked with electromagnetic induction, right? Because when we move magnet through the coil or through any conductor, so it will generate uh, induced EMF or the induced current. So this part is actually linked with electromagnetic induction. This is basic, so we can write this answer easily. This part is actually linked with electromagnetic induction. This part. So when you pass magnet through the coil or through any conductor, so due to change in the magnetic field lines or due to the change in the magnetic flux linkage, an EMF induced or the value of induced current will be there in the coil, right? So this is the idea we are writing in this part of the question. So magnetic field lines cuts the copper tube and due to change in magnetic flux linkage, an EMF induced in the copper. So again, you can see in this question, they are asking explain. So definitely you have to give reference of any specific idea linked with the current in the copper because of magnetic field. Part 2, the current in the copper produces a magnetic field of its own in the tube. Now, this statement is different. The current in the copper produces a magnetic field of its own. One magnetic field is due to the permanent magnet, and definitely when there is a current in the copper, it will generate its own magnetic field. Again, the idea of this electromagnetism, basic concept, this one. And the magnet falls much more slowly in the copper tube than in the plastic tube. It falls much more slowly as compared to plastic tube. Explain why the magnet falls more slowly in the copper tube. So basically, uh, if you think like in simple words, you know that if something is moving slow, so definitely there must be some other force acting in the opposite direction to resist or to like stop that body in moving opposite to that. So same thing happens over here. An upward or the opposite force acts on the magnet because there is magnetic field generates by the copper itself. So that is the magnetic field of the copper, and magnet has its own magnetic field. So there are two magnetic fields. So due to those two magnetic fields, one force generates over there, and that force try to resist that magnet to move in downward direction. That's why magnet is moving slowly as compared to the plastic tube, because in plastic there is no resistive force. It is mentioned in the first part over here, but when it is moving in a copper, so we know that copper is a conductor, and definitely it will resist because of the magnetic field. So we will explain like this. There is a force acting in upward direction because the magnetic field of the copper produce force that opposes the motion of the magnet. So magnet tries to move in downward direction, but due to the magnetic field produced in copper tube because of electromagnetic induction, so that force will not allow the magnet to move in downward direction properly. So it will like apply or exert opposite force on the body. So that's why magnet moves slowly as compared to the motion in the plastic tube. Okay, this is also related to transformers, so just skip this part. Electricity, electricity, electricity. Okay, mostly questions are like from new paper to the old are related to the electricity part. Again, it is related to the electricity. Electrostatics, AC. Hmm. Okay, if we try this question, it is like slightly different from the other that we practiced before. So define EMF, electromotive force.
Like given off from battery to like push electrons, free moving electrons to complete the current.
Okay, okay. So basically in EMF, it is linked with the battery and it is the voltage of the battery. So we can define it like work done on a unit charge. To drive this charge, round a complete circuit. In part B, it shows a circuit. We have battery, then from P to Q, we have a wire that is connected the circuit from point P to point Q. Then we have two lamps. So there are two identical lamps, and each lamp has a potential difference of 3 volts across it and the current of 2 ampere in it. So current is 2 ampere, potential difference is 3 volt, PQ is a length of uniform metal wire and the resistance of PQ is R. Calculate the value of R. So basically PQ, the resistance of this wire is not given. Current is given. Current is 2 ampere and the potential difference of each lamp is 3 volt because both are connected in a parallel combination. So definitely they have same voltage and the total EMF of the battery is 12. So definitely from 12 we subtract 3, we will get 9. So the voltage of this wire is 12 minus 3 because both lamps are connected in parallel combination and in parallel combination we have same voltage. So the voltage across point P and Q is equals to the 9 volt. So resistance is equals to V over I. Current remains same because Wire is in series combination. Round of 4 amperes. Another piece of wire is made up of same metal as PQ. The length of the new piece of wire is twice. Length of new piece of wire is twice the length of PQ. The diameter of the new piece of wire is twice the diameter of PQ. So diameter is double, length is double, 2 times length, 2 times cross-sectional area. Now calculate the resistance of the new piece of wire. Resistivity is same. We know that it is directly proportional to the length, inversely proportional to the area. So what do you think? What will be the resistance of the new wire? Okay, one more thing that we made mistake in the first part. In question, it is mentioned the potential difference of each lamp is 3 volt and current of 2 ampere. So basically 2 ampere is for single lamp, 2 ampere, 2 ampere. So both are connected in parallel. So basically current divides into two parts. From here, it divides into two parts. It means the total current passing from PQ is equals to 4 ampere. So we have to correct this value. This is not 2, this is 4. And it will be equals to 0.25, 2.2 ohms. Now this is correct value. So now what actually happens, we know diameter is given and diameter is like twice of radius. So resistance is directly proportional to the length and it is inversely proportional to the area. But we know that diameter is given, area is not given, right? So diameter is actually 2 times of the radius and area is equals to pi r square. So r square means if diameter is twice, so radius will be like 4 times 2 into 2, 4 square of 2. Length upon area. So it will be equals to 2 times length. So final resistance will be equals to 2 over 4. It means 1 over 2. So it means your resistance of new wire decreased by the factor of 2. It means it will be half of the first value. So new resistance is equals to 2.2 into, sorry, divided by 2 because it is half of the actual value. 1.1 ohms. Again, electric current. Again, electric current. Yes, we have this question, DC motor, starting from here. Figure 7.1 shows two magnets and the gap between the north pole of one magnet and the south pole of the other magnet. Okay, so that is shown in the diagram. On figure 7.1, draw three lines to show the pattern and the direction of the magnetic field in the gap. So that is simple from north to south. Because they are only asking in the gap part, right? So that's why we only draw the line in the gap part. Part B on figure 7.2, it is a repeat figure of 7.1 showing the two magnets. Okay. Now on figure 7.2, draw the position of a plotting compass needle when it comes to rest in the gap between the north pole and the south pole. So when we place a plotting compass in the rest, when it comes to rest in the gap between north and south pole. So when we place that compass in the gap between north and south pole, like at this point, so we know that it will also represents the direction of the field from north to south. So previously we know it is moving from north to south. So definitely it will also show you direction of the needle towards south because it shows you field is moving from north to south. So compass also moves with the direction of the north pole. Simple. So we place this plotting compass in the middle because it is already mentioned in the question. Draw the position of a plotting compass needle when it comes to rest in the gap between north pole and south pole. So between north and south pole, we place a compass and it shows the direction towards the south pole. Now explain why the needle comes to rest in this position. So we know that in the compass, we have a needle with north pole. So that north pole is attracted by the south pole. So that's why it comes into rest state. Because in any other direction, there is a like curve field lines. So when you move the compass, so definitely the pointer of the compass also changes direction, just like the reference of the field lines. But in the center, we have a straight line from north to south because from the center, field line is moving straight from north to south because north pole, south pole both are opposite poles and they attract each other. So same happens with the needle of the compass that the north pole of the compass or of the needle of the compass attracted towards the south pole. And the reason is, unlike poles, attract each other. So this is the reason. Okay, now demagnetization is no more included in our new syllabus. So we just ignore this part.
Oh, it's already?
Yes, because it is, you can see it is from 21. And in new papers like 23, there is nothing like demagnetization if you search in your syllabus also. So you will not get any concept related to demagnetization. That's why we also not studied in our theory part also.
Ah, okay.
You may skip this part, right? Because earthing is also like excluded. So that's why it is also excluded. Now we have DC motor, and it shows a simple DC electric motor with a split ring commutator, brush, coil, split ring, north, south. Okay, state and explain the direction of the rotation of the coil as seen from point X. So you have to state and explain the direction of rotation from point X. So point X is like we are observing. So point S is the observer at the point where we are sitting. So we have to identify the direction of rotation according to this. So magnetic field lines moves from north to south. And if you noticed one thing, previously we are solving question number 7, right? And in this part, we will get 8, right? This is because I remove those questions which are not included in new syllabus, but this part is like in a part of our syllabus, and we from this diagram we can solve at least this part. So that's why I only include this part just for practice. Okay, so a magnetic field is moving from north to south, and according to the direction of current, you have to check by yourself because it is not given. Current is moving from this direction because this is positive and this is negative end from this. So current is moving in this direction from left hand side into the page from right hand side. So from right hand side, it is moving into the paper, and from the left hand side, current is moving out of the paper, right? So now you have to use left hand rule to identify the direction of the force, that in which direction the forces are acting. You may also take reference from left hand rule. This is left hand rule. First finger magnetic field, second finger electric current and force. So if you place first finger, like this is the direction of first finger, and if we consider right hand side, because it is easy to mark direction for right hand side, so we consider right hand side. Current is moving, sorry, we consider left hand side because current is coming out of the paper. So if we consider left hand side, so from left hand side, it is very simple to identify the direction of force. First finger like towards right hand side, second finger is out of the paper, like second finger is pointing towards us. and the direction of force is upward, right? So it is like same orientation. We have to just slightly switch this direction from left hand. So you will get same force in upward direction. So we are getting force in upward direction from left hand side. So definitely from right hand side, we will get force in downward direction. So in this way, coil rotates in this direction, right? So left hand side coil moves in upward direction and right hand side coil moves in downward direction and it is moving clockwise. So a statement will be clockwise and explanation is very simple because force because in this space we will not explain whole idea that we apply left hand rule and current is moving in this direction, force is acting in this direction. You just explain the simple method that we use. Force on left side of coil is acting in upward direction and force and in downward direction on right using Fleming's left hand rule, right? So this is the explanation for this part. Okay. Uh, the coil rotates through 90-degree from the position shown. It means perpendicular. Can't we give explanation with the reference of the current? Yes, you can mention that, but that I feel that will be like a lengthy uh answer for you to write in this space. So it's up to you if you want to explain according to that, because I only mentioned the reference of Fleming's left hand rule and the main quantity that we identify is the force, because in left hand rule we used to identify force, current and magnetic field both are given, you need to identify force. So if you explain this part with the reference of force, that is also fine. And if you want to explain with the reference of current, so that will be like slightly lengthy, but still you can also use that part for your explanation if you want. So now coil rotates through 90-degree, like perpendicular to the position that is given in the diagram. Now what happens to the moment in the position? So we know that it is horizontal and when it rotates through 90 degrees, so it becomes perpendicular. So in perpendicular, we know there is zero torque, like zero turning effect or zero moment. So we will write zero turning effect, or in short, zero moment. And the coil is rotated through 180-degree. So 180-degree means right side is now shifted towards left, left side is shifted towards right. So from the position shown, by considering the force on the coil, explain how the split ring commutator enables the motor to turn continuously. So basically, the coil is rotated through 180-degree from the position shown. So now you can see, let's suppose this is left hand side, this is right hand side. So after 180-degree rotation, this left will shift it towards, sorry, right side will shift it towards this one, and left side will shift it towards the other side because of 180-degree rotation. So when we have 180-degree rotation, so right side is converted or rotated through left. Now the direction of current changes in that side. And if we consider left hand side, so left hand side is now moved towards right hand side, and the direction of current for this left hand side as compared to the original position is also changed. This is the same idea we discussed over here in this pattern, right? The highlighted part is on left, current is moving in upward direction over here, but after 180 degree change, so now current is moving in downward direction. So the direction of the current for that same side changes. So same things happen in this part. Okay. So we will mention in this part that the current in the coil reverse and the direction of force and rotation remains the same. So only sides like switched with one another, but the direction of rotation, direction of force remains the same. So this is the simple answer for this question. Okay, let's try this one also because it consists of a circuit. So let's see how this circuit works. You don't need to learn the complete working of any type of material because always diagram will be given in the question. So according to the diagram, according to the concept that you learn in electromagnetism, you can identify the working by yourself. Just like in this question, let's see. We have figure 10.1. In this, you can observe we have switch over here that is open. When we close this switch, so current starts to flow in this rod that is in the coil and it becomes magnetized. And when it becomes magnetized, so this side will attract it towards this solenoid and this part, because there is a pivot, this rotates in upward direction and there is a contact and this circuit will complete. So you can see there is very simple mechanism. Let's see what they are asking in the question. Okay, now switch in circuit A is closed. Describe how this operates the motor in circuit B. Okay, so that's simple. We come close this circuit, and when you close this circuit, so what happens actually? This L-shaped soft iron armature rotates about the pivot. It will becomes like this. It is attracted towards this point, So it makes a contact, right, with this solenoid, and on the other side it also makes contact like this. Okay, so pivot remains in its original position. My rod is slightly displaced from there, but I hope you got the concept what happens because it is pivot and it is free to move from this point. So it becomes magnetized. Uh, it produces magnetic field and the soft iron armature magnetized, and this part attracts towards this solenoid. And when it attracts towards the solenoid, so due to rotation, the upper part also connects with the contact. And when these contacts are in contact with each other, so it will complete the circuit and motor starts to operate. So this is the simple mechanism. So we just described the mechanism. When current it generates magnetic field and soft iron core. This soft iron armature, sorry, is attracted towards solenoid. It rotates about a pivot point and contacts in other circuit, joins, and current starts to flow. Motor in circuit B. So you can see it is not compulsory to learn all the process, all the working of any specific component. It is very easy to identify if you know the basic idea. Now, switch A in circuit A is open. Now it is open. The soft iron armature is replaced with a steel armature. Okay. Now soft iron is no more. There is a steel. The switch in circuit A is closed. So explain what happens when the switch in circuit A is then open. So we know that steel is a permanent magnetic material. So if we close the circuit and open the circuit, so steel remains magnetized and electric motor still continue to work because steel armature becomes permanently magnetized and it will remain in the same position, just like we draw in the diagram, right? So basically, steel remains magnetized when there is no current in the circuit. So it remains magnetized permanently even when there is no current is moving through the circuit. So this is the concept of this setup which is given in the question of relay. Okay, if we consider this question also, question number 10. So it shows an incomplete circuit and a student completes the circuit and measures the current in the 6 ohm resistor. On figure 10.1, draw an ammeter symbol in one gap and a straight line to indicate wire in the other gap to show how the student should do this. Okay. So in one gap you have to draw ammeter and in the other gap you have to draw the wire to show how the student should do this. So we will like draw ammeter in this part. So ammeter is connected in this point. And now we have to draw a wire to complete the circuit. A voltmeter is connected to measure the potential difference across the 4 ohm resistor. Now again you need to draw a voltmeter symbol connected in the correct position. So voltmeter always connects in parallel combination. So this is the combination of voltmeter. With the circuit completed, the current in the 2 ohm resistor is 2.5 ampere. Okay. Calculate the current in 6 ohm resistor. So value of electric current through this 2.5, sorry, this 2 ohm resistor is given 2.5 and the other resistor 6 ohm. So what is the value of current in the 6 ohm? We have given the value of current in 2 ohm resistor, 2.5 2 ohm resistor, this one 2.5 ampere. So this resistor gets 2.5 ampere of electric current, and we don't know about 4 ohm resistor, and we have to find out the electric current through this 6 ohm resistor. Yes, 6 ohm. And you are getting 4 marks. It means it is not like a simple calculation. So first of all, we know about resistance and current, right? So first of all, we find out the voltage through this resistor. So voltage through 2 ohm resistor is equals to I into R is equals to 2.5 into 2. So 5 volt is the value of the potential difference passing through this one, 2 ohms. And next, if we talk about the electric current, in the second one, in this resistor, 4 ohms. Hmm, a student completes the circuit, okay. Potential difference is given, right? Resistor is 2.5. 5 volts is the voltage, okay. And the total resistance of these two resistors will be parallel combination 1 over 2, 1 over 4. So we can also find out total resistance to find out the value of electric current passing through their combined value. So if we combine them, the parallel combination, so 1 over 2 plus 1 over 4. So in this combination, we will get the value 4 over 3. So the combined resistance of these two resistance, that is 2 ohms and 4 ohms, is equals to 1.3. So this is the total resistance of these two combination, and now we got the voltage also. So by using Ohm's law again, V is equals to IR, I is equals to V over R. Pi divided by 1.3. 3.8. So 3.8 is the total current passing or dividing like between these two resistors, right? So it means 3.8 ampere current is passing from this side, and when it reaches the junction, so it divides into 2 ohm and 4 ohm resistor. So 2.5 is passing through this 2 ohm resistance. So if we subtract 2.5, so rest of the 1.3 is passing through this second resistor. So combined current is passing 3.8. So basically first we find out the voltage because we know that voltage remains same in parallel combination. So we got 5 volts. So 5 volts is passing through this 2 ohm resistor, same will passing through the other one. So we got the total voltage of this two resistor combination, and then we find out the total resistance. So total voltage, total resistance will give you the value of total current that is dividing between these two resistors because in parallel combination current divides. So the total value of electric current we are getting 3.8. So that 3.8 also passes through this 6 ohm resistor because 6 ohm is in series combination. So the total amount of electric current passes through this resistor. And in part B, figure 10.2 shows the same electrical circuit when an alternating current power supply and a wire in the gap AB. So this time we have AC power supply and a wire in gap AB. Okay. So AB, previously we have voltmeter, but this time we have wire. On figure 10.2, draw a diode symbol in one gap and a straight line to indicate a wire in the other gap. So there is a current from right to left in 4 ohm resistor and an alternating current in the 2 ohm resistor. So you have to draw diode in this way that there is a current from right to left in 4 ohm resistor. So in 4 ohm resistor, current passes from right to left because this time we have AC, not DC. And secondly, alternating current passes through 2 ohm resistor. So we know that when we have to fix the direction of electric current, we have to use diode because diode only allows the current in one direction. So they are saying current from right to left in 4 ohm resistor. So right to left means we have to connect diode over here in this point. So current only flows from right to left in this direction through 4 ohm resistor. And we have to connect just a simple wire to pass alternating current from side CD. Okay, any confusion in this part? So mostly you observe now we are at air October, November 22, like 22, sorry, 2020, 21, 22, 23, 2020. So in these like 3 or 3.5 year variation, you observe there are very few questions related to DC, right? You are getting more questions like electricity questions are, we observe they are greater in quantity as compared to electromagnetism, right? You observe we missed many questions like this is from electricity, this is from AC transformer, this is from electromagnetism, AC transformer, electricity, magnetism, DC, electricity, So basically, if you practice electricity part very well, so according to the past papers, you observe that the questions of electricity are greater in proportion as compared to electromagnetism in new years like 23, 22, 21, and 2020. Plus, from electromagnetic part, we are getting more questions from electromagnetic induction like AC generator and right hand rule. So practicing the questions like in a sequence in past paper will help you to guess the topics, right? So if you already done with electricity, so definitely you will get easy marks from the past papers question, and that will give you confidence also that you are able to solve electricity section. Plus, tomorrow, inshallah, we will practice electromagnetic induction question like from AC generator and from right hand rule, because you observe many questions we skip are related to the right hand rule and the transformer. Still, there are many electricity questions that we just left as homework. You can see this part is also linked with AC, electromagnetic induction. So tomorrow we will practice electromagnetic induction with AC generator also. So that will help us to identify the number of questions from AC also. Like today we got like mm, maximum 3 question I think from simple DC motor part in this 3.5 years variants. So that is like very less number of questions from DC, right? And tomorrow when we practice AC, so let's see how many questions we will get in the same variants of the paper as compared to the DC. But still, the weightage of electricity part is more in new papers. It is not compulsory that in your final exam you will get a compulsory question from electricity, but these are like facts from past papers that we drive during the solving of the past paper questions, right? So inshallah, tomorrow we will start with electromagnetic induction and the right hand rule, AC generator concept and transformer. And tomorrow we will also end up this electricity section, practice section session. And after that we will start nuclear. Nuclear will take like 1 day maximum. We will solve many questions from the nuclear because that is short section. So still,
So do
let's
you know by when we'll start the practical practice?
ATP, yes. After completing the nuclear, right? In this week, inshallah, tomorrow we will complete this theory part of electricity, and on Wednesday we will complete nuclear part, right? And for space physics, like on Thursday, I think there is no exam or any one of you. So I will check out. If there is no exam, so in that class we will practice questions from space physics because there are like few questions. So
So
on
this Thursday?
yes, this Thursday.
So I have an exam.